Welcome to this lesson on variables. My name is Donna Martin and I'll be your instructor. In this lesson, we're going to cover characters, integers, floating point numbers, how to name variables, and then there'll be a quiz. Now, by characters, we are talking about a variable type that allows you to store individual letters or characters in them. And then integers are just whole numbers. Floating point numbers would be real numbers, things with a decimal point, like 6.5. Then we're also going to talk about how to name variables, what the rules are in C, and then after that you'll be doing really well and you'll be able to pass the quiz. So here we go. As we already mentioned, all variables must be declared before you can use them in a C program. So usually at the top of the program, you declare all your variables with their types and their names and any initial values. A declaration involves exactly those things, a type and a list of variables of that type. There may also be initialization clauses in there as well. So we saw before in the previous program, for instance, we had float area. Area was our variable name. It's a real number, and so it is of type float. Now, we mentioned earlier that there are no predefined types for variables. What I mean by that is that some languages, like Fortran, have rules that all variables, for instance, that start with the letter I through the letter N are considered integers automatically, whole numbers. So all you have to do is, if you have a loop counter, you usually call it I because that's an integer and it goes through, 1 through 10 times or whatever. But C doesn't have any rules like that. So you must declare every variable that you need to use, give it the name, and tell it what type it is so we can go out and allocate the memory and know how to utilize that variable. So again, you can't assume your variables that start with I or integers. Now, a lot of people do that. If they have loop counters or integer variables, they tend to follow that naming style, but that's just a convention. It's not a rule in C. All right, so the variable declaration, as we've already seen, may include an initial value. If it does not, then you don't have any idea what's in that memory location. So in the case of the float of area before, we didn't set it to an initial value when we declared it. Now we calculated a value for it and stored that in there, and then we printed the value of the result of that calculation. So we were storing something in the memory location before we printed it. But when we first created it, we have no idea what's in there. You're not guaranteed for a normal variable in a program that it's going to be any value. So don't assume like it's going to be initialized to 0 or anything like that. The initial guideline, and the reason that's important for you, is that let's say that you're going to do a running sum. You're going to do a calculation and add up a bunch of numbers and store them in a variable called sum. Well, you need to make sure that sum starts at 0, or who knows what your answer is going to be because you don't know what the initial value is in sum. So it's undefined unless you specifically initialize it. So you just need to make sure that your variables are initialized before you use them. In the case of when you create them, like when we set radius to be 2.5, or when you are calculating them and you store it in that location and then use it later on. Both of those would be acceptable things. We also saw that you can declare more than one variable per type statement. You can't mix types on a statement, but if you have 6 floating point numbers, you could say float, A, B, C, D, or value 1, value 2, whatever they are. You can declare them all in one variable, all in one line. You don't have to have 6 separate float declaration statements. All right, so here's the example we saw before, float area, where we had an uninitialized variable called area, and then we had radius, which we initialized to 2.5. Now, I want to tell you that this style of mixing a variable that is a float that is not initialized and a variable that is on one line is not commonly recommended. It's called hiding the initialization because basically what will happen if you add more things to the end of this line. I'd like to take another example where we're adding another variable that's a floating point variable. you can see that we kind of lose track of the initialization of radius to be 2.5. So it's recommended that if you have variables that are going to be initialized, that you do them in their own declaration statement. It's not a requirement. C doesn't care. We're just trying to make it easy to read and easy to see what variables are actually being initialized to certain values. So you might do something like this, like we saw when we were talking about comments, where float area is on one line and then the radius initialization to 2.5 is on another. Some people will put all their initializations together. Some people will put them on separate lines. So there's all types of advice out there on how to best do that. But the main thing is you just want to make sure you're not losing. You don't have to search for the fact that you initialized a variable. Now, eventually, we won't actually be initializing radius to 2.5 in our program. We're going to go out and ask the user for a value or read it from a file or something like that. But we haven't learned how to do that yet, so we just set it to a value that we used in our calculation. All right, so let's look at now how we name variables. We've seen area, we saw radius, but let's go over the rules. Variable names in C have to begin with a letter or an underscore. And we recommend a letter because system variables tend to start with underscores, so that you don't ever have to worry about running into a conflict with a system variable. We recommend you start your variable names with a letter. Variable names can consist of letters, digits, and underscores. That's it. That's all you get. So you have to become creative in naming your variables. You can use any of the letters, any of the numbers, and underscores as well. Upper, lowercase letters, whatever you want. But that's your restriction in terms of the types of characters that you can use. So no spaces in variable names and no special characters. No semicolons, you can see why. No dollar signs, that type of thing. Certain names are reserved and you can't use them as variables, like void or int or float, or there's also a data type called a char. Those things you're not going to use as your variable name because it would be confusing. Those are reserved words. All right, so upper and lowercase characters are allowed. So you can have a variable called a. If it's a variable that's an uppercase a, that's different than a variable that's a lowercase a. So if you're going to mix cases in your declarations or in your variable names, you just have to make sure you're consistent so that you don't end up getting an error message from the compiler because it doesn't know about this mystery variable that you created because you forgot to capitalize it in one of the uses that you did. So just be careful if you're going to mix cases. But again, here in this example, char capital A and little a are two separate and different variables. And you'll see this, you don't see this type of thing for regular values like number 1 and number 2. You wouldn't have one be capitalized and the other not. But in the case of characters, you might have it in case you are storing an uppercase a into the character variable capital A, and you're storing a lowercase a into the other variable. Okay, so there are places that you would want to use the same variable name with different cases, but in most normal variable naming situations, you're not going to deal with that. All right, so it's traditional to use primarily lowercase. If a variable is all uppercase, we tend to assume that that's a symbolic constant. That's what that pi was in our previous examples. So a symbolic constant is something that's done in a defined statement for the C preprocessor. So if we're looking at your code and we see something that's all uppercase, we're probably going to assume that that's a defined somewhere. So we traditionally don't use all uppercase for variable names, though it is legal, and you're welcome to do that. But most people looking at your code would probably assume it's a symbolic constant. All right, how long can a variable name be? Well, it can be as long as you like. There is a limit for what's unique. Only looks at the first 31 characters. So only the first 31 characters of a variable name are significant. Now you're probably not really going to run into this. I can't imagine somebody naming a variable with 30 characters and then have an A and then the same variable, the same 30 characters B, like supercalifragilistic A and supercalifragilistic B. We're not going to see that type of thing, especially because you're not going to want to type that long. And I don't imagine I would get a 31 character variable name correct every time that I use it in the program. But those are the rules. Variable names can be as long as you like, but only the first 31 are significant. So they have to be unique within the first 31 characters. All right, so let's look at some variable names, and you can apply the rules we just talked about, and now we'll see if they're valid or not. So here's some valid variable names. Area. We already saw that in previous programs, so you can assume that yes, indeed, it is valid. It starts with a letter. It only consists of letters, but it could have underscores and digits in there as well. But area is indeed a valid variable name. Value, all uppercase, is also a valid variable name. Again, you probably wouldn't traditionally use this in your program unless it was, because we're going to assume it's a constant, but it is a valid name if you wanted to use it. Maximum underscore value is also a valid variable name. It consists of letters and underscores. Minimum value with a capital M and a capital V distinguishing the words is also valid. The only thing you have to be careful of is every time you use it that you capitalize it in exactly the same way. But some people like to use the underscores to separate words. Some people like to use changing the case to separate words. So that's your decision. A lot of people also probably wouldn't use quite this long of a variable name because even though it's self-documenting, it can get tedious as a programmer. So you have to pay attention to, things like that for your own sanity. When you're creating variable names, you don't want it to be so long that it just makes it difficult. But you do want your variable names to have reasonable values. You don't want it all to be A, B, C, D, E, F, G, because then you have no idea what your program's actually doing. All right, let's look at a few more. Now, the ones we're going to look at now are invalid variable names. So I'm going to bring it up and just give you a second so you can kind of see what it is and why it's invalid before I tell you. So here's the first one, 10%, but it's 10%. So what's wrong with that variable name? Well, the answer is that variable names cannot start with a number. They have to start with a letter or an underscore. So this is invalid because of that. It can't start with a number. Char, C-H-A-R. That's invalid because it's a data type. That's a reserved word, so you cannot use that as a variable name. 3-D. That's invalid because you're allowed to use letters, underscores, and numbers, not dashes. Because C would not see this as a dash, it would see this as a subtraction sign. And would actually think you were trying to take the variable 3 and subtract the variable D from that, which is not what you would be going for here if you're thinking this is your variable name. So that's an invalid variable name because dash is a special character. It's actually so it's not allowed, but it's also just the fact that it's not a letter, a digit, or an underscore. And here's the last one, wish underscore upon underscore a underscore star. And again, this one's invalid for the same reason as the one above. It has a special character in it. Variable names are letters, digits, and underscores, and the star is not one of those. It also happens to be the multiplication character, so it would get confused because it thinks you're going to want to multiply something, and that's again not what you're thinking about. All right, so keep in mind those rules we just talked about, that letters, digits, and underscores has to start with a letter. And what you're going to do is take a little quiz. There's a quiz on the site that you can go download. On the course page, under the course materials tab, you'll see a quiz for this particular module, and you can look at a whole series of variable names. They'll ask you if they're valid or invalid, and then you can answer that and then look at the solutions. So you take the quiz and check the answers. There's also an interactive online quiz that you could take if you'd rather do that. All right, after you've taken the quiz and got everything right and know that you understand variables, we're going to be going on to the next section. We're going to start doing some different things with variables so we can start doing some more serious programming. Thank you for joining me for this module, and I hope you'll join me for the others.